Hi everyone, I'm Jim White, and this video is about what the world needs: one more hot wire foam cutter. There's all kinds of videos about hot wire foam cutters on YouTube, and one of the reasons for this are there are many different uses. I'll show you the one that I made for a particular purpose, and if you're interested in that application, you might want to include some of the features in your foam cutter. Now, first of all, you may not even need a hot wire foam cutter for some foam applications. There's a special blade made for saber saws for cutting foam. It's basically a knife edge that you put in the saw in place of your normal tooth saw. You can sort of make your own out of a standard blade by grinding the teeth off. However, the blade that you buy for cutting foam and cardboard is a little thinner. Now, it does a nice job on cardboard, and the beauty of it is there's no sawdust. So it's a clean way to cut cardboard and foam. Let's cut a piece of cardboard with it. Oh, you can see it does a nice job on cardboard. This is expanded foam, whereas this is called extruded foam. This extruded foam is much firmer, and this is used a lot in building materials. And the expanded foam is used a lot in packaging and things like that. Styrofoam cups are expanded foam. Well, I broke that by pulling on it too much, but you can see it cuts that type of foam just fine. Here's the extruded foam. I had a little piece on the end here that I cut off, and hopefully you can see it makes a very nice smooth cut. No sawdust. So if that would suit your need, you may not need a hot wire foam cutter. This is my hot wire foam cutter. I use it to cut pieces of foam to do lost foam casting with aluminum. I have a forge that I can melt aluminum with and do the lost foam process. Here are some examples of aluminum castings that were done using foam and the lost foam process. Now here's two pieces of foam like the ones that were used to make this piece. The foam pieces were stuck vertically down in a bucket of sand, and then the aluminum was poured until a puddle formed on top to connect the pieces together. Now the vertical wire is used to cut out patterns in this usual manner of doing it. Manner is what I meant to say. Now, in order to cut out inside holes, this wire needs to be removed so that it can be passed through the foam. And I don't know if you can see it, but the wire just has a loop on the end of it, and it can be unhooked from the spring bar that's holding it up. That piece of aluminum is bent down, and it's acting as a spring to pull the wire up. You can hear that it's under tension. Then there's another wire on the end of the unit, and this wire can be positioned up and down along this stud, and it's used to slice foam to reduce its thickness. I'll pick that up later. On this end, there's another aluminum rod acting as a spring to put tension on this wire on the end. And you can hear there's tension on that. Now there's a third cutter here. That's a piece of nichrome wire. It's soldered to 2 pieces of stainless steel welding rod. And yes, you can solder nichrome wire and stainless steel wire, but it takes a special flux. And I'll show a link to that flux under the Show More tab. So in the back here is a 10-volt transformer and my on-off switch. And I have an LED circuit there to show when the transformer is on. And there's also some resistors here that are used to control the current. I can tap along these resistors to vary the total resistance in the circuit. So that's the basics of the my hot wire foam cutter. And I'll demonstrate the various cutters here when I attach the camera to the tripod. Here's a setup for using a rail to do a straight cut on a piece of foam. The foam cutter is on feet raised high enough that a clamp can get under the edge to hold various rails. Now here I've disconnected the wire from the end and put a jumper in its place to complete the electrical circuit. And when I do that, I have to put all the resistors in the circuit to compensate for the resistance of the wire. So let's turn on the power and cut this piece of foam. Now I can crank up the power to where it'll cut the foam much faster, but you lose tactile feedback when there's no resistance of your force. So you've got to reach a current level that makes it feel good to you as you cut out. I'm going to now hook up the wire on the end and slice one of these in approximately in half. Okay, now I take my resistors out of the circuit. Okay, there we have approximately cut the center to form two pieces. Then the wand allows you to do things like that. So I think you get the idea there. Now, foam like this is available in 4-foot by 8-foot sheets at places like Lowe's and Menards and Home Depot. And you can get it up to 2 inches thick also. Now, several of those places have 2-foot by 2-foot pieces for $6 or $8, something like that, of the 1-inch material. So that's a good way to get a small piece to start playing with. I've also bought 4 by 8-foot sheets and cut it up right in the parking lot till I could get it in my vehicle. Now the expanded foam you can find at those same big box stores, usually in packs 1 foot wide by 4 feet long. And I think there's 5 or 6 pieces per pack. And do note I don't know if you can see it, but the texture on this foam, if you use it for casting, like I showed you, this texture will come out on the final casting. Also, this foam cuts very easily, so you actually need to reduce the current to get any kind of a force feedback on your cut. The nichrome wire that I'm using is 0.025 inches in diameter, and that's roughly 22 gauge. And you get 69 feet of that on a 1/8 pound spool for $14 and some cents. Now I've measured it at the cutting temperature that I like at 1.2 ohms per foot. And I measured that I'm running 3.5 amps under those conditions. If you used a smaller diameter wire, you could run at a lower current. But you'd have to watch your total ohms based on whatever voltage source you're using. The wire runs through a hole in the base. Let me flip this over. And I have a stainless steel welding rod that's running to the hole in the center from the stud that's on the top of the base. So the wire, my cutting wire, it's just a loop that's hooked over the end of that rod. And I believe that was Gorilla Glue that I used to stand the wire off of the base. So you saw cutting of foam with the 025 wire at 3.5 amps. Now I also have some 0.020 wire, which is 24 gauge, and I'm going to replace this wire, the 025, with the 020, and we'll see what current works out good for cutting the foam with that size wire. Okay, this is how to unhook the wire. Push down on the aluminum bar and pull it off with a little stud. So you can see here how far the spring action is. So now, next I have to unhook it from the bottom. And I may need, oh, there we go. So I'll make another wire like this out of the 020 wire, and then we'll cut some foam. Okay, I've put an ammeter in the circuit so we can see what the current is. And this is the 020 wire. Now the 10-volt transformer is going through these resistors, which is 1.5 ohms, and through the wand, the cutting wand, through this wire, and through these wires, or this wire here. So there's quite a bit of resistance in the circuit. Got to turn it on. And it takes a second or two for the wire to heat up. Now we're at 2.25 amps there. And I can feel resistance as I cut here. But I like that. If it's too easy to push the foam, you don't seem to have as much control when trying to follow a line or something like that. Now I could take the current up by shorting out part of this wire here. Let's go to 2.5 amps. There we are, 2.5 amps. And you can see it cuts a little faster. So let's go to 3 amps. There's 3.04 amps. And you see it cuts even faster. Now I have some wire that measures 0.01 inches in diameter. So I've made it the same length with a loop on each end. And we'll see what current this cuts best at. Okay, I have replaced the 0.02 inch diameter wire with a 0.01 inch diameter wire. That's a 30 gauge. It's about 7 ohms per foot. I measured about 2 ohms from here. Remember, there's a wire running from here to there. And I measure 2 ohms between here and here. So I have about 2 ohms worth of the fine wire. I measured the total circuit resistance with the manual cutting probe and the side wire and the 1.5 ohms here, and it measures 8 ohms. And the voltage on the transformer, it's nominally 10 volts, but at light loads it will raise a little bit. So we have about 11 volts into 8 ohms, and we're getting about 1.35 amps. Now the finer wire also has to melt less material. So you can see it cuts nicely. But the downside of the fine wire is it is quite hard to work with, and you could not do something like a cutting wand because it would not be stiff enough. Now there's many ways to build a foam cutter. I used things that I had on hand. I had a piece of plywood. MDF would serve the purpose just as well. Medium density fiberboard, it would be less expensive. This is a piece of aluminum that I had on hand that I made 2 pieces out of. This could be steel. It could be much smaller than this. You could even use a yardstick if you ran a piece of wire out to the end to make the connection. So mechanically there's many ways to do it. I use a piece of stainless steel under here. You could use any stiff steel. I just happen to have stainless steel welding rods laying around. The transformer that I used was something I had on hand. We'll discuss that further. We'll talk about the electrics next. But mechanically, I think it's pretty obvious. There are many ways to build this, and your intended purpose would probably go a long way in determining how you do it. Through the magic of video, I just made a change here to make things simpler for you. I got rid of the resistors that were there and replaced them with a piece of the Nichrome wire supported by some screws. And now the resistance can be varied by where you make a connection to the wire. Now I used a toggle switch because I happen to have it, but then you got to make a bracket to mount it. What would be probably simpler would be to mount a outlet box on the back here with a standard switch that's probably less than $1. By the way, I found that even Menards has alligator clips, so I assume the competitors do as well. Here is the wiring diagram for the foam cutter that I built. This represents the plug, and here would be the line cord. And this would be the on-off switch. I used a transformer that I had on hand, so my unit uses AC voltage. A DC supply of a fairly low voltage would work fine also. I have a circuit here to light an LED. All these numbers ending in -ND are DigiKey part numbers. DigiKey is a supplier of electronic parts, and you can get any of these parts at digikey.com. Now this transformer is rated at 10 volts and it's center tapped, which means it has two 5-volt windings. So you can hook it up to supply either 10 volts or 5 volts. This resistor is selected for the 10 volt supply. So if you run the hot wires from 5 volts, leave the LED circuit on the 10 volts. Now I used 18 gauge hookup wire for all the interconnections. Here's the DigiKey part number for that. At Menards, the smallest wire I could find was number 14, and you can use that if you would like. Even as small as 22 gauge wire would work fine for this application. Now this dashed line here represents the cutting wire or wires. And as I said earlier, I used 22 gauge Nichrome, which is about 1.1 ohms per foot. And this wire, or this dashed line, represents the current adjustment wire. And this arrowhead represents the alligator clip, which can be moved along the wire to adjust the current. Now this is Ohm's law. The current in amps equals the voltage in volts divided by the resistance in ohms. So if you had 3 feet of the Nichrome wire, that's about 3.3 ohms. And you divide that into the 10 volts and you would have a minimum current of 3 amps. You could then raise that current by sliding the alligator clip along the adjustment wire. Now if you had considerably less wire, if you had 1.5 feet of wire, you could move this wire to the center tap and supply 5 volts to your circuit, and you could still have a minimum of 3 amps and could go higher based on where you put the alligator clip. Now here's metric conversions if you want to work in the metric system. Here is a listing for Nichrome wire on Amazon.com. Here's a listing for a soldering flux that they claim will work on stainless steel, so it should work on Nichrome. I've never used this, so I can't vouch for it. The flux that I use is no longer available. And finally, let's talk about safety. If you're not familiar with house wiring and are not comfortable working at 120 volts or above, have someone else help you with the wiring. Now there's no electrical shock danger from the 10 volt circuitry. You can touch any of this stuff while it's live. But remember, the wires are hot. Both the current adjustment wire and the cutting wire are physically hot and you can get burned. Also, fumes will be given off while you're cutting foam, so be sure to work in a well-ventilated area. So good luck with your foam cutter, have fun, and we'll see you in the next video.